All right, so this is the lesson on definitions and postulates, just kind of an introduction to geometry and what it looks like. But I'm going to review some of these Algebra 1 skills that we talked about from the last unit. So I'll go ahead and pause the video, try these warm-up problems, and then after that we'll go over them. All right, so I'm looking at this one. I see that this whole expression is being divided by -2, so I'm going to take each of these terms and divide it by -2. So when I do that, I get 12 divided by -2 is -6. I'm going to keep the variable, which is x. -20 divided by -2 is +10y. And then 14 divided by -2 is -7z. Okay, and then I'm just going to carry over this plus 5z. All right, then after that, I'm just going to combine like terms, the two z's, and I get -6x plus 10y minus 2z, and we're done. All right, now this is, don't really say this, but I'm looking at this and I know I'm going to create a algebraic expression for this written expression. So twice the product of a and b. So 2 times, product means multiplication, a and b, or 2ab. And we're done. All right, over here we see here we have a proportion, so we're going to cross multiply. So this is 32 times 3, which is 96, equals, then we do 4, and the tricky part is to always make sure you put this expression in parentheses, b plus 4. I'm going to distribute 96 equals 4b plus 16. Then we're going to subtract 16 on either side. We get 96 minus 16, which is 80. Okay, I'm carrying it on over here. Equals 4b. We'll divide by 4. 20 is equal to b, and we're done. All right, so that was just a little review. All right, so we're going to go into some definitions that are going to be important for geometry. So first definition is a point. Okay, point has no dimension whatsoever. It's just a dot that represents a location. So an example of that would just be this. And then we usually label it with a letter, so I'm just going to use A. So that is a point. All right, a line has one dimension and extends without end, okay? And any 2 points form a line. So I'm just going to create 2 points, A and B. And this is important that they have no end, so these are going to keep going in both directions forever and ever. All right? Then a plane is two-dimensional. Okay, so imagine like a floor or a wall without end. So these are still going in either direction. But any 3 points on the same, or not on the same line. So if I had another point here, that would still be a line, right? But if I have, let's say, a line here, all right, and these are extending in either direction, and then I'm going to add a third point not on that line. So we'll say this is C. This can form a plane, okay? And again, these are, imagine this just kind of extending in all directions. That is a plane. All right, a line segment consists of endpoints, A and B. So they gave us these points this time. So let's say A, and we have B, and points, and all their points between them. So we have 2 points that are connected, and then a line segment is a bunch of little points put together in between. So that is a line segment. So it has a beginning point and an end point. Then a ray has an endpoint, so let's say endpoint A, and then continues without end in one direction. So keep going in one direction. And it could have a point on it as well, so we can do that. But this is our life, right? We have a starting point, then with the Lord we go on and on forever and ever and ever. So that is our destiny when we believe in Jesus, is a ray, okay? All right, so opposite rays. So if point C, so we got to do some drawing. We got AB over here. And then point C is in between A and B, okay? Then CA, okay, and this is a line, so we have a line over here, okay? CA and CB are opposite rays, so they're going opposite directions in their rays. Opposite rays. This is the definition of opposite rays. All right, so here's some examples of what you're going to be asked. So you're just kind of going to be looking at a diagram and you're going to be interpreting what it means. So looking at this diagram, give two other names for PQ and plane R. Okay, so even just looking at this, all right, PQ, I'm just going to kind of write it like this, and then I'm going to write the names underneath. Okay, so we need two more names, 1, 2, 1, 2. So we need two other names for both of these, okay? So we're just looking at this, we can tell, okay, PQ and QP are the same thing, okay? So that's easy. So that would always be another name, is just reading it the opposite direction. Then the other thing you notice is how we have a little n up here. So we can actually name this line by saying line N. So QP, PQ, or line N. Those are three different ways to name that. All right, plane R, okay, is this one right here. So what we need to do is we need to find 3 points that are not collinear, meaning collinear means the same line. Okay, so we're just gonna pick a line that's on there. So PT, plane, so I'm gonna draw a little symbol for plane. P, T, and then we're gonna pick another point, so not on the same line. So S is on the same line, so we can't use that one, but we can use V over here. Okay, so V. P, T, and V, okay? We can pick 2 points on the same line, but the third point cannot be on the line for us to name that. All right, then we're gonna just pick another name. So we can reorder these. That could be another name for it. Or we can use PSV. So let's do that, PSV. So just 3 points on that plane that are not collinear. All right, then we're moving on to this word that I've been using, collinear. Collinear just means on the same line. So point S, point P, and point T are all collinear because they're all on the same line. We couldn't pick P and Q because there's not a third point on this line. All right, name 4 points that are coplanar. So we're gonna look at this. We have 1, 2, 3, 4. 4 of these points are all on the same plane. Now, is Q on this plane? No, it's outside of this plane, so we couldn't use that. But point V, point S, point P, and point T are all on the same plane, so that's what coplanar means. All right, moving on to example 2. So give another name for GH. So GH, we obviously know HG is an easy way to name that, and that's the only answer. Or I guess you could also name it GH, or not GH, JH or JG, because they're all on the same line. But HG is an easy answer for that one. All right, name all rays with the endpoint J. Okay, so there's a lot of these. So we got J, JG, and I'll just kind of draw a little symbol like that to show that it's a ray. J, I'm just going to go around. JE is a ray. JH, and then JF. Okay, there we go. Which of these rays are opposite rays? So we know GE and, or not GE, why do I keep calling this a G? JE and JF are opposite rays, so I'd write JE. They're opposite rays because they're going in opposite directions, so JE and then JF. These are opposite rays. And then another example would be JH and JG. Okay, because they're going opposite directions. Okay, and you kind of want to include where the arrow is going. So if my arrow is pointing this way, it needs to go with the H. Okay, so basically the starting of point of this ray is at J, so that's where the dot is going to be. All right, moving on.